Good morning, guys. Welcome to the webinar today. We're going to be talking about analyzing root cause and end user impact using AWS XRay. My name is Abhishek Singh. I'm the general manager for AWS XRay. As part of the webinar today, we'll be talking about a few different things. We'll start with monitoring and debugging modern applications and why do you need tools like AWS XRay. We'll do an overview of AWS XRay. Then we'll get into the root cause and end user impact analysis using XRay. We'll talk about the use cases here, and then we'll do a demo. And finally, we'll go to Q&A. So let's begin with monitoring and debugging modern applications. All right, so let's talk about why traditional debugging does not scale for modern applications. As you can see on the slide, modern applications are composed of multiple services. So in this case, I have three services: a front-end service, a back-end service, and a payment service. And then I have a database that the back-end service talks to. Traditionally, what developers have done for debugging services or applications is essentially a local test, logging, breakpoint loop, essentially, if you will. And while traditional debugging works really well for monolithic applications or a small subset of services, you can see very quickly that as the number of services grows, it can become very difficult to debug applications that are highly distributed in nature. Part of the challenge here is essentially correlating the data across each of these services. So imagine that you have an exception in the payment service that then gets propagated up the chain to the backend service and eventually goes to the user from the front-end service. In this scenario, if you were using traditional debugging tools, you would essentially start with the front-end service and begin debugging there. Once you found the appropriate user request, you would essentially see that the error came from the backend service. Then you'd move on to debugging the backend service and follow the same exact process again, eventually realizing that the error came from the payment service. And finally, in the payment service is where you would see the actual exception being thrown. So essentially wasting a lot of time going through the process of looking at services individually and not at the user request end to end. So let's talk about tracing for modern applications. As I showcased earlier, that debugging applications with traditional tools or modern applications with traditional tools doesn't really scale well. If you start using distributed tracing, that then provides a user-centric view for debugging applications. So in this case, what would happen is that you would capture a single log of your user making a request to the front-end service, which then uses API Gateway, which then would make a call to your backend service running on EC2, which then makes an API Gateway-based call to your backend service, or a payment service in this case, running on Amazon EKS and AWS Lambda. Now, since the log or the trace is capturing the end-to-end transaction, you don't have to go look at the logs for the individual services. You get that user-centric view just from a single trace. So let's hop into how AWS XRay helps here and how you can use AWS XRay to solve this debugging problem for modern applications. XRay provides all the capabilities of traditional tracing solutions plus some more. It is outright built for modern applications. With XRay, you can quickly analyze and debug issues with your containers and serverless components. Once you've instrumented your code, you can quickly get an end-to-end view of individual microservices. This is very important since you can specifically pinpoint any issues across services. You can also identify individual service impact while understanding the root cause of an issue and who the end users are that are impacted by those issues. XRay is also portable across clouds, so you can actually use XRay with various cloud providers. You can use XRay on-prem. You can use XRay when you're debugging your applications locally. So XRay pretty much will run wherever as long as you can make a connection to the XRay endpoint in AWS. Specifically, XRay helps developers analyze and debug applications built using microservices and serverless architectures, enabling developers to identify the root cause and end user impact very quickly. What we've heard from our customers who are using XRay today is that they've gone from reducing their mean time to resolution from anywhere from half a day to hours to a few minutes. Some have even said that they can get to the root cause of the issue or understand end user impact in seconds. So let's look at what you need to do to get started with XRay. The way XRay works essentially is that you instrument your application with an SDK. And at the end of my demo, I will show you guys the GitHub repositories that contain the source for these SDKs. So they're all open source. And I'll also show you guys our samples GitHub repository that contains various sample applications or various instrumented applications, I should say, for various platforms. So for example, if you're running on Kubernetes and you want to instrument your applications, we have a blog post as well as a sample GitHub repository that walks you through that. If you're running on Fargate or ECS, similarly, we have samples for that. Same thing for Lambda-based solutions. And then we have specific examples for each of the languages that we support. So once you've instrumented your application, the way XRay works is the SDKs essentially emit, you can call them events, log segments. In the XRay terminology, they're referred to as segments and subsegments to a daemon. The daemon is essentially the collection agent, which then takes those fragments and send them over to the XRay service. The XRay service collects all of these fragments and then creates what we refer to as the trace. And from the trace, it aggregates a view that is called the service map, which essentially shows you all the connections across your application. And finally, we provide an analytics view and a trace list view that enable you to drill into the services and understand why you're seeing essentially issues or exceptions in individual services. In terms of the instrumentation, we have a strong open source community. We support 6 different language SDKs today. So those are .NET with .NET Core, Go, Java, Python, Ruby, and Node.js. We also support AWS App Mesh, and we're working on upstreaming support into Envoy, the proxy that is the data plane for App Mesh, if you're interested in that as well. Now let's look at what XRay does for your modern application. So we looked at the slide earlier and we said, this is basically what a trace looks like. It's the end-to-end transaction from the user all the way to your payment service, and then the response back to the user. In terms of the XRay terminology, we refer to the data emitted by each one of these services as a segment. So in this case, the front-end service emits a segment, the API gateway is emitting a segment, your backend service emits a segment, the second API gateway also emits a segment, and then the EKS service as well as the Lambda service emits segments in each of their cases. We also have a notion of a subsegment. So subsegment is any remote call that is made from within a service. So in this case, the backend service is making a call to DynamoDB. You can also instrument any local compute operations and create or generate a subsegment from those as well. So imagine you had a fairly compute-intensive operation. Let's assume you're calculating the Fibonacci numbers in your backend service. You can actually wrap that into a subsegment so that you can see that on the trace as a subsegment or a data point that captures the timing around that function. And finally, the combination of all of this is what we refer to as a trace. So the trace is the end-to-end visualization, if you will, of a single or an individual user request through your system. Now, as I mentioned, XRay takes the traces that are captured and aggregates them into a service map. So in this case, what we have here is a sample e-commerce application. So this is what we're going to use for the demo as well. So I'll sort of use the time here to walk you guys through what the application looks like, so you're familiar with the components. So in this case, I have two ingress points to my application. I have the www endpoint, which is where clients access my service or my e-commerce website here. And then I also have an API endpoint where clients are calling either the APIs directly or through my front end, which is calling the API. I have an authentication service that validates users for login purposes. So that's the auth service, AUTH. I have a customers DynamoDB table. So this is a table that's storing my customer information. I have a product service that essentially contains the listings of my products, which is backed by a products DynamoDB table. I have some serverless components in this application as well. So I have an API gateway, which is in the prod stage here. And I also have a staging or dev stage, which is not shown here. But behind the API gateway, I have two services. I have an order service and a shipping service. So the order service is what records my orders. And then the shipping service is used to print my shipping labels essentially and enable my backend folks, if you will, or operation folks to send out the packages or the products to customers. Now let's quickly jump into the meat of the webinar here. So how do we go about analyzing root cause and end user impact using XRay? In this section, we'll specifically cover two features of XRay. One is called XRay Groups, and the other is a newly launched feature that we just launched at the end of April called XRay Analytics. The Groups feature essentially enables you to focus on certain workflows and then generate metrics from those so that you can create alerts. And then with the Analytics feature, we will look at how do we identify root cause of issues and then determine which users are impacted and by how much. So as I mentioned, there are situations where you want to focus on specific workflows in your application. So let's say you just want to get visibility into requests that came into the payment service, for example. Or you want to look at requests that are slow, right? So let's assume you have a service level objective of providing API access in less than a second. In this case, you can create a group that says, show me transactions that took longer than a second, and XRay will automatically group those and create that data view for you. Additionally, what you can do is using the metric that XRay emits for all transactions that took longer than a second, you can create an alarm which enables you to alert anytime you have a certain number or a certain percentage of requests that took longer than your threshold of 1 second. This enables you essentially to increase visibility on selected services or end users. Specifically, as you're building applications, if you're not focused, for example, on the overall view, you don't want to look at everything that's happening in your application. You just want to focus on a specific intent or a specific API. XRay Groups is the mechanism to enable you to do that. The way XRay Groups work is if you go to the XRay console and go into service map, traces, or analytics, it's the same bar on the top. But on the top left is where the group shows up. And if you click on it, you can actually go and create a group if you don't have one. Everybody who's using XRay has a default group. The default group essentially contains aggregations for all traces that are sent to XRay. One of the other things that Groups enables you to do is not only does it just create the visualization for the request, but it also splits up the metrics that are captured for each one of these services and edges on the service map. And we'll look at this a little more in the demo, but I just want to call that out because a lot of folks miss that. They think it's just a visualization component where if you create a group, you get a nice service map that is for the subsection of your overall service map, but that's not the case. We also essentially look at the metrics and slice them for you so that when you're looking at the service map for a group, you're looking at the data that's relevant only for the set of requests that meet that filter expression. So in this case, when you go to create a group, it's pretty much as simple as providing it a name and then giving it a filter expression. So for those that are not familiar with XRay's filter expression capabilities, I'll do a quick recap. In XRay, you can create filter expressions that search the graph. So essentially look at services and edges, and also look at annotations, which is business data that you can attach as key value pairs to your transactions, or properties of the traces themselves. So if you have a HTTP application, you can look at the URL, you can look at the status, method, and various other HTTP properties, for example. In this case, we have a fairly complex filter expression, and we chose this on purpose just to show you guys the power of the group's capability. So in this case, what I'm specifically querying on is I'm looking for all requests that contain an edge where the beginning of the edge is a client, so it must start at a user essentially, and the end of the edge is an API. And the request contains a service of type API gateway stage. So in this case specifically, the name of the group is serverless API. So as you may have guessed, I'm looking for all transactions that start at the client and go to the API and contain my API gateway in them. So again, fairly powerful ability to define groups after the fact, right? So this is not something that I defined when I wrote the application. This is something that I'm defining on the fly because I've gone through an issue, let's say on my serverless API, and now I want to increase visibility on that. So I can go into XRay, create this filter expression, and lo and behold, I have the ability to then look at just the serverless API and the transactions that meet that criteria. So this is what that looks like. So if you remember the larger service map, it had a lot more components than just the serverless API components, right? So in this case, we're looking at only the pieces that interact, that begin at the client, end at the API, and then have a serverless component to it. One of the other things that you'll notice, and I'll point this out in the demo as well, is that if you look at the metrics within the nodes themselves, so the average response time, the number of traces per minute, these numbers will change from the default group to the API or serverless API group. Part of the reason this happens is because, as I mentioned earlier, XRay is slicing the data and is only aggregating data from transactions that meet that filter expression here. So again, I'm just showing you another example. So let's say you wanted to get alerted on every time there's a fault in the system. So in XRay, the notion of a fault is any unhandled exception, right? So you can just create a filter expression that says fault, and then what happens is XRay emits a metric called fault, or the approximate trace count for the group fault. And this gives you the number of traces at any given time that meet that criteria. And so in CloudWatch, you can very quickly go and create alarms then based on that metric. Similarly, let's say you wanted to create an alarm or a metric for a very specific API, right? So in this case, the serverless prod service, which is my API gateway. And then if the response time from the API gateway is greater than 1.5 seconds, right? So again, this is not the end-to-end response time. This is the response time only for that service. So I can then go and create a group for that, and then similarly track that in my CloudWatch metric as a number, and also in XRay as a list of traces, for example, that I want to go debug. Now let's look into XRay Analytics. So we just launched this at the end of April. XRay Analytics essentially helps you to quickly and easily understand any latency degradation or increase in error or fault rates that you have. We show you the latency points for the 50th, 90th, and 95th percentiles. We also show you the root cause or also critical path for what is going on or what's causing the requests in your application to be slow. We focus on end users and not just tell you who the end users are, but also tell you, what the impact on them is by doing a statistical comparison. We'll talk on that. And then we provide you with the ability to compare across two sets of groups or two sets of data points so that you can actually see the statistical differences between them. So looking at the same application, the e-commerce application that we saw earlier, let's see how we can use XRay Analytics to understand the root cause of what's going on. So if I'm looking at the console here, what I want to do is essentially I pick the region of latency that's greater than 1.5 seconds. And then very quickly, what XRay does is it tells me that Emma is the user that's impacted most by slow requests, right? So you can see on the table down below that Emma is impacted 38% of the time. Similarly, what happens is, so in this case, that's the selection that I made, and then the filter was added to response time. So as you can see here, a couple of things pop up. So the number of 500s in this area of response time is essentially higher, but I can't quite know if this is statistically correlated, right? So I know that a large number of requests are getting 500s. I don't know what is the overall notion of requests, right? So it's totally possible that most of my requests that end up taking a longer time have something else also going on. But I can't quite tell that from just looking at the percentage of traces that meet that criteria. Similarly, as I mentioned earlier, we have the user here, so you can look at the user. One of the things that XRay Analytics introduces is this notion of root causes, or you can call them critical path, for those that think root causes are more than just what's going on in the system. So in this case, what XRay is essentially telling me is that XRay analyzes all the transactions that meet that filter criteria, right? So in this case, the filter criteria is anything that took longer than 1.5 seconds. And then XRay is analyzing all of those traces. So in this case, thousands of transactions. And we're essentially looking at the graph of your request and then telling you what part of that request is causing your request to be slow. So in the specific example that I've chosen here, the number one reason for my requests to be slow, actually, if I combine those two DynamoDB weights, ends up being almost, I would say 90+%. So essentially, I'm waiting for DynamoDB to return to me a response. Now, we all know DynamoDB is pretty fast. And if you're provisioned appropriately, this shouldn't happen. We also know that most of the times, if you're using Dynamo, you should be using batch operations instead of single object operations. So very quickly, I can actually go look at the individual traces here. So I can actually click on one of those, look at the products API, and then look at not just the root cause, but also the message, right? And if I look at the message, what XRay is now telling me is that 97% of my transactions were slow because I exceeded the provision throughput exception. Now, having written the application, I can very easily look at this error message now, and the light bulb sort of goes off. Oh, I'm getting throttled by Dynamo, which is leading to retries. And because the retries are exponential, I know that I'm spending a lot of time in my requests. So all I need to do here is increase my provision throughput, and I can solve the problem for 97% of my customers. Similarly, as I mentioned earlier, analytics lets you compare trends across two sets of data. So in this case, what I'm specifically doing is looking at pre and post deployment. So the blue represents, if you will, my blue version of the deployment, which is the version that was running. And then green represents my green version or my new deployment. And as you can see, if I look at some of the data points, and so in this case, I ended up deploying at 3:40 in the morning. Guess, somebody somebody reported something and I had to fix a bug, right? So I had to go do a deployment early in the morning. But very quickly using XRay, I can look at the comparison and I see that, the new version of the deployment actually is 32 percentage points more likely to return 200s versus the previous version, right? So I fixed some bug, which essentially is now resulting in a larger number of 200s, which means my application's working better. Also, you can see that the percentage points or the delta in 500s has reduced by about the same percentage point, right? So essentially what my new version has ended up doing is that it's fixed whatever bug I had, which was resulting in 500s. So all of those requests are now resulting in 200s. And XRay Analytics is very quickly showing that to me and enabling me to essentially prove to myself that whatever fix I just deployed is actually having the impact that I expect. All right, so let's hop into the demo here, and I'll try to do the analysis part of this live so that you guys can get a sense of how easy it is to do. Let me halt this slideshow and we'll sort of hop in from there. Okay, perfect. So here I have my XRay console. I have the service map. So as you can see, it's the same exact service. I've got my www endpoint, which is the front end for my application. Similarly, I have my API, which is where I'm collecting, if you will, the API data points, or that's how my application essentially works. That's the back end. And then I have a bunch of other services, right? So I have my order service. I have my orders DynamoDB table. I have some remote services. So these are services that are not instrumented with XRay. They happen to run on Elastic Beanstalk. So think of these as third-party services, right? So for example, if you had login by Facebook or payments by Amazon or Square, you can still instrument and get those services essentially shown on the service map, so that if you have a downstream dependency that's causing an issue, you can very quickly look at the service map and understand that it's happening because of a dependency and not because of your own service. In this case specifically, what I'd like to do is, let's quickly look at these colors for folks that are not familiar with the service map. So green is success, purple is throttled, orange or yellow is errors or in HTTP 4XX, and false or exceptions in this case are red, which is 5XX in the HTTP error code or status code terminology. Now, I see that I have a bunch of users having a poor experience in my www service. So I can just click on that, and I can analyze this in 3 dimensions from this point forward. I can look at a response time. So if I'm not happy with how fast my service is, I can essentially analyze by selecting a response time window and then analyzing based on that. Or I can actually go in and look at faults and errors. So in this case, I want to focus on the faults because this is where my customers are having a poor experience, right? So let's kind of click on faults and then do view traces. And so what XRay did essentially was we automatically generated this filter expression. And you can click on this question mark here to get a sense of all the possibilities for filter expressions. So I just want to leave you guys with that. I won't get into the details here in the interest of time. But as I'm clicking through these various screens, XRay is automatically generating these filter expressions. So you don't necessarily need to learn the terminology if you just want to use the console and click around. Second thing what's going on is once I created the filter expression, XRay gives me this nice group by capability. And by default, it's grouped by URL. So very quickly, I can see that my product's URL or path and my front end, which is my storefront, are the two that are most impacted by faults. I can go split this up across various attributes. If I want to look at users, again, I see that Emma and Olivia are the two most impacted users. And then across Emma, Olivia, and William is when I have most of my user impact, essentially. And users essentially is annotated in your code, right? So when you're instrumenting your application, you can add this user value. Similarly, I can look at client IP. In this case, I'm just running a load test. So you see that I have a single client IP. But you can have, this is essentially a high cardinality metric in some sense, where you can have thousands of client IPs or even possibly millions of client IPs. It doesn't really matter. XRay would show them all to you. We have instance IDs. So if you're running, for example, in EC2, you can look at the instance IDs and get a sense of whether a specific instance is causing issues. So this would be a notion of a lemon, for example. And then you can go look at some annotations. So here I've annotated a few different properties, if you will. So I've annotated the notion of credentials being cached, if the user was authenticated, if the ACL cache was hit. I have cold starts for my Lambda annotated. And then I should have some number of queries in here, which I'm not seeing right now. So I'll kind of skip that for a second. But the point that I was trying to make here was that you can go look at a few of these things, right? So if I want to look at products, for example, I can just click on products, the filter expression gets updated, and then I can continue to split this data in different ways, right? So I can look at the mode, and then this says it's clean. I can look at fault injected, which is true in this case. So again, this is my sample application. So I'm obviously instrumenting this to make some of these things obvious. And then in this case, what I'm seeing is, if I look at the ACL cache, so 94% of my requests are hitting the cache, 5% aren't. But this view is not really giving me a sense of what the correlations are, right, across these various data points. It's great at letting me kind of dive deep into a specific set of traces, but didn't really tell me what's correlated and how I can understand sort of the root cause. So what we're going to do is, and this is what we introduced at reInvent last year, is the notion of root causes. So let me go and just go back to faults, and then show you guys the root causes. So as I mentioned, you can analyze things on 3 separate dimensions in XRay. There is the notion of response time. So we have a response time root cause. There's errors, which are essentially exceptions that your program is handling. And then there's faults, which are unhandled exceptions, right? So in this case, I'm looking at faults. So let's start with fault root cause messages. So if I go to faults, what I'm seeing is that for a majority of almost 99.9% of my applications, I end up with an internal error. Now, this is not very helpful. So let's look at the fault root causes, which is where it tells me the path of what's going on. So if I look at the path of where this is happening, I can see that it's my product service that's returning 99.9% of the errors. So I can actually click on the product service, and then we have this filter pop up here. And then I can go look at one of these example traces to understand what's actually happening. So as you can see, what XRay has done is that it went through this graph of your request across thousands of requests, in this case, tens of thousands of requests. And it analyzed the fact that your product service is what's causing the internal error, right? So if I click on this, now the internal error message was not very helpful, but because I have a stack trace here, I can actually go look at my function hello.go line 591 and figure out what's going on, because that's where the error is actually happening, right? So went from a not very helpful error message or exception message that I was capturing to the line number of code where I can go look and figure this out. So again, very, very helpful to understand sort of where to look and pinpoint the focus of the developer so that they can figure out what's going on. Now, similarly, if I were to look at error here, so these are exceptions that I'm catching and not passing on to the user. Once we're done scanning here, so we kind of went through and looked at 100,000 traces. We picked 10% because again, you're not going to look at 100,000 traces by hand. So we sample that for you. And then you go and look at the error root cause messages, right? So in this case, what I'm seeing is 100% of the errors were because authentication failed for Noah. So I have some user called Noah who's trying to log in and they're failing authentication. If I look at where this error is happening, I can go look at, it's happening from www to the auth service. So again, I can click on this. I can go look at one of the traces. And what I see is that my auth service is returning an error on function, again, hello.go on line 548, where we're failing authentication for Noah. So again, very easy for me to start with just a notion of how my service is doing, and then dive into which part of my microservices are causing issues, and then who are the users that are impacted. Let's quickly hop into groups just so that I show you guys what that looks like. So in this case, here's where I have groups. I've got a few different groups, but let's look at faults and pay attention to the split of these nodes essentially, right? So the metrics in here. So you see that the red part of it is a little less than 20%. But if I go to faults, what XRay is doing is the map just got updated, and then that became 100%, right? So now the map here represents 100% of the requests that ended up in faults, and I can actually go start digging into that if I wanted to. Not super helpful in this case because I could have done faults another way, but the reason this is helpful essentially is that if I go to fault, what I have now is a metric. So I'm going to go into the view metric page here. And this is where the power of groups essentially comes in, right? So what I have is I can look at the faults over time now. And because XRay is emitting the number of traces that match this criteria, this is essentially a metric that I created from an arbitrary filter expression, right? So the filter expression says false, and now I can get a metric on false. I'll take this a step further. So we created a dashboard here for XRay. And so in the XRay dashboard, we give you the default group, which is all your transactions that the system is processing. And then we give you some of the other numbers, right? So in this case, I'm looking at faults. So as you can see that over time, I have these spikes of faults that happen seems like every half an hour or so. And it's really easy for me to then start doing metric math on these things and creating alarms, right? So I can take the overall volume, which is this, and I can plot that against the faults, and that will give me a rate of faults that I have. And then I can say if the rate of faults is more than 2%, create an alarm. That's something that's very powerful with the group's capability. So I wanted to call that out. From there, let's move on to analytics. So I've preloaded the analytics page. And here I wanted to showcase to you guys some of the use cases around essentially understanding what's going on, but also deployments and being able to compare across groups, right? So we start off with just the capability of arbitrarily filtering what's going on, right? So you can move this and you get a live filter of what's going on. And as I'm moving this out, a couple of things are happening, right? So let's say I want to look at a request that took longer than 1.5 seconds. What I see and what's interesting on this time series activity is that these requests that take longer than 1.5 seconds have some notion of time corresponding to them, right? So it happens right at 10 a.m., happens right around 12 p.m., then happens right around, let's say 1:30. So there's something that's going on that's causing this to happen, every hour or every 45 minutes or so. I also see that, let's actually take out the filter. So I also see that the majority of them end up in 500s, as we had seen in the slide deck. And then I see Emma is the user that's most impacted by this, right? So one of the things I want to call out as I'm doing this is that you can actually click on any of these tables and continue filtering the data further. So I will click that out for a second. And now let's look at the comparison. So I see that, a bunch of these traces end up in 500s. I don't really know it's because somebody's sending me some bad request or there's an issue with the service. It's not. It just gives me a notion of how many of these are impacted, right? So what I can do with XRay Analytics is I can actually do a comparison. So let's kick out the filter, and then what I'm going to do is hit the compare button. So what this does is it takes or locks the current set as the base set, right? So I want to compare against the whole population, if you will. And then now I have the B set, which is active. And what I want to do is I want to go select the B set to be 1.5 seconds or longer. And what this tells me is statistically, normalizing for trace volume, the requests that took longer than 1.5 seconds are 66 percentage points more likely to end up in 500s. If I look at the users, this is very interesting, right? So Emma is the one that has the most volume, but she's not the most correlated to the number of 500s. So if I look at slow requests, it's actually Olivia who is most impacted by this, right? So Olivia is almost 4 percentage points more likely to be impacted by slow requests than anybody else in the population or any of your users in this case. So this is where the power of XRay Analytics comes into play, is that we do the statistical analysis for you so that you can understand not just the correlation of things, but also look at causality, if you will. If I follow down this table, I can similarly go look at things like the instance IDs, right? And so in this case, you can see that I have 3 instances that have 30 percentage points more likelihood of ending up in slow requests than otherwise. Now, one of the things just to highlight, we specifically have an example of a lemon that we baked into the sample application just to show you guys what that looks like. So let's actually go in and find the lemon path here. Actually, it might be easier. I don't see the lemon path here. But let's look at the errors, for example, right? So I clicked on errors, automatically filtered by the URL. And then I see the instance IDs, but let's actually just hit compare and compare it with everything. And so again, what I'm seeing is, these 3 instances seem to have twice as much likelihood of causing errors similar to what they have for slow requests. So there's something obviously going on with these 3 instances that I can then go diagnose. I was trying to find a scenario where one of these popped out, but in this case, seems like I have 3 of these, and they might end up being in the same AZ. And we've specifically made that use case where you see batches of 3 around the same sort of percentage points or delta here. So ideally, as you can see, that these should hover around the 8 or 9 percentage points across the board. But in this case, I have 3 of my instances that not only have a higher likelihood, but they're also serving a majority of my requests. So I have something going on here in terms of routing where these instances are being sent most of my requests. Or they have something else going on, maybe a networking issue, for example, that's causing them to return slower requests. So again, quickly showing you guys the power of XRay Analytics. We start with the response distribution. We show you activity over time. So just so that you have a sense of, as you're filtering, how often something happens. Is it happening all the time? Is it happening only sometimes? That's what the second graph gives you a notion of. And then each of these tables essentially are configurable, and you can look at any of these properties, including your business annotations, and start doing comparisons and statistical analyses on these to understand what's causing issues. We also have the root causes tables here. So if I go back and look at the greater than 1.5 second, I can actually just go do this. And then I can hop over to the root causes. And since it has response time root causes, I can see that the majority of my requests are slow in my product service calling my store API. And then in here, it's a longer path to DynamoDB. So let's actually look at one of those. And if I look at one of the traces, what you can see here essentially, and this is kind of what I was getting at, right, is I'm making a call to Dynamo, and then I have these growing or exponentially growing weights. So I have weight 1 here, 2, 3, 4, 5, right? So these exponentially growing weights kind of add up. And if I look at what's going on, each one of these returns a provision throughput exceeded exception, right? So the reason these are failing is because I don't have enough throughput, and I can go and increase this throughput. I also have the request IDs. So if I believe that I'm getting this in error, I can actually cut a ticket to DynamoDB or support and tell them to forward this to Dynamo with the request ID so that they can go and look at this particular request on their backend as well. So with that, I'm going to quickly end the demo. But as you guys can see, the power of XRay from the perspective of not just understanding what's going on, but also being able to analyze things and understand root cause and customer impact and go from there. So let me hop back to the slides here. I don't believe I have anything else left in the slides. Well, let's go look at that. All right, so we had the demo, and then I want to thank you guys today for taking the time to view the webinar today. It's great. Now we're going to move into the Q&A section, and we'll take your questions and hopefully answer all of them. I did want to show you guys one thing. I mentioned I would show you guys the GitHub repositories. So let me actually end the slideshow quickly and just show you guys where those are, just so that you guys have that information. So if you go to github.com/AWS, and in here, let me actually go to AWS, not the daemon. And so within this repository, I can search for XRay. And this will show you all our SDKs. So you have the XRay SDK for Python, Go, Node, Java, the XRay daemon, which is also open source, .NET and .NET Core, and then Ruby. Similarly, if you wanted to look at the sample applications, you can just go to github.com/AWS-samples. And in here, you can just search for XRay. So you can see we have examples for Fargate, Kubernetes. We have a .NET application. We have a Kubernetes and serverless combination applications. We have the ability to send CloudWatch events. So that's a sample application that shows you how to do that. We have a Lambda sample application. We have a sample application that uses our APIs for plotting things. So this essentially shows you time series data using our APIs. And then serverless, and then an Apache Kafka sample as well. So, just wanted to show you guys 2 of these resources just so that they're available to you. But once again, thank you very much. Appreciate you guys taking the time today to view the webinar, and let's move on to Q&A. Thank you.